In this particular case, we see that CUDA and Metal, so an RTX 3090 running NVIDIA CUDA, an Apple laptop 1 Pro running on Metal, both do very, very well. Token rates are very respectable, with Vulkan on an AMD R9 Vega 64. So this is an older card, but exactly the thing that you might expect to see in perhaps a Kwaai lab, where you've got somebody saying, I got all this gear, what can I do with it? This will run inference. What'll it do? Turns out it passes only about 50% of your tests, and it does so slowly. Yet the newer standard, ROCm, on an AMD RX 800 XT fails at a 14.3% pass rate at a very slow token throughput. Here's the interesting thing about this one. That wasn't actually a model failure, but it was a fixable misconfiguration. Once that was corrected, then that same machine passes at about 94.6%. So exactly what you would expect of a modern framework on a modern-ish card. Actually, this is a modern card. It's actually newer than the 3090. AMD is just lagging behind on their ROCm deployment compared to NVIDIA's CUDA. But what's interesting about that is you're running it, and if you run the test or you're on your workload and you don't know that you've got this software problem, you can end up with failure because it falls over to CPU, and nothing tells you about that. So if you're not measuring it, you're not actually looking at the truth. You're just understanding what comes out the other side. If you have a way to measure it, then you have something that's worth exploring further and worth comparing to other stacks and other users, etc.